In this section, we're going to look at what a complex conjugate is, and we're going to look at how to divide complex numbers. So let's say we've got a complex number, z, which is a plus bi. Well, this complex number has what's called a complex conjugate. And we denote the complex conjugate by z star. And to get the complex conjugate, we're going to leave the real part as it is. So the real part of z is a. So we're going to leave that as it is. And we're going to times the imaginary part, which is b, by -1. Or you can think about that as you flip around the sign of the imaginary part. So plus bi becomes minus bi. Another way of thinking about that, or writing that, would be to say that the real part of the complex conjugate, so the real part of z star, is the same as the real part of z. A hasn't changed. But the imaginary part of z star is equal to minus the imaginary part of z, because the imaginary part of z was b, and we times it by -1 to get the imaginary part of z star. Minus b equals minus b. Let's look at some examples of complex conjugates then. So we've got, let's say z equals 3 plus 7i. Then z star, in this case, would be equal to 3 minus 7i. We've just changed the sign of the imaginary part, or times the imaginary part by -1, however you like to think about it. Let's say we had another complex number. Let's say we had a complex number y, and y was equal to 10 minus 2i. Then y star, the complex conjugate of z, of y, leave the real part as it is, 10, and change the sign of the imaginary part. So times -2 by -1 to get plus 2i. Let's look at example 7 then. So we've got a complex number z, which is 2 minus 7i. So z star, we're going to leave the real part as it is, 2, and change the sign of the imaginary part. So we've got plus 7i. We're asked to find the value of z plus z star. So let's see what we get. Z is 2 minus 7i. You could put that in a bracket, but you don't need to, because we're adding them. Plus the complex conjugate, which is 2 plus 7i, sorry. Adding them together. So let's collect together the real parts. We've got 2 plus 2, which is 4. And we've got minus 7i plus 7i, which is 0i. But we don't normally write the 0i, we could just write that as 4. So notice that z plus z star is a purely real number. Sorry, that should say equals. Because the minus 7i and the plus 7i cancelled out. And that's always going to be true. So z plus z star is always going to be a purely real number, where the imaginary part is 0. Let's look at C. We're going to have z times z star. So this time we're going to use brackets because we're timesing them together. So we're going to have z minus 2 minus 7i times by 2 plus 7i. So we can expand the bracket to get 4 plus 14i. And then we're going to have minus 7i times 2, which is minus 14i. And minus 7i times plus 7i. Minus 7 times 7 is minus 49. I times I is I squared. So let's try and simplify that. We've got 4 minus 14i plus 14i, cancel each other out to get 0i, but I'm not going to write that. And we've got I squared here, which is minus 1. So we've got minus 49 times by -1. So we're going to have 4 minus 49 times -1 is plus 49. So we're going to have 53. And notice that in the middle, we're always going to have two terms that cancel each other out, because we'll have one positive and one negative. And that's always going to be the case when we do z times z star. And then you've got I squared, which is always going to be minus 1. So if you do z times z star, and there's lots of questions like this in the exercise, z times z star is always purely real. You're always just going to get a real number like 52. It's going to have an imaginary part of 0.